into the night sky and wondered what lies beyond? Have you ever felt the infinite cosmos call out to your very consciousness? Well, I have. My name is Aviraj Singh Dhaliwal, and today I'm here to take you on an infinite journey. Not only through the cosmos, but through the intricate workings of the human mind and its insatiable curiosity. I vividly recall the moment when this spark within me was ignited. I was but a small child, about 9 years of age. On a dark, moonlit night, I snuck out of my house, pointed my head up, and saw the thousands upon thousands of stars gleaming down on me. I pondered what amazing stories they might have to tell me. And within the next few years, I learned all I could about this wonderfully mysterious subject, be it from YouTube videos or from sci-fi movies like Interstellar, Gravity, and Passengers. Around the 9th grade, physics began to separate itself from the other two branches of science in our textbooks. My excitement knew no bounds. I knew that I could learn more than I ever had, but my classmates did not share the same enthusiasm. I tried to bring the light of physics, the beauty of it, to their eyes, but all they could see was boring blobs of text pasted in our textbooks, failing to see the hidden beauty behind this amazing subject. From that day forth, I vowed to bring the beauty of this subject to the blind haters and to prove its usefulness for once and for all. Now, enough backstory. Let me get right into the fun stuff. I'm sure that all of you have heard of quantum mechanics. It's a field of physics related to extremely small particles like electrons, protons, and neutrons. And yes, it is just as interesting as its name makes it sound. A curious thing I've noticed is that an electron is both a wave and a particle at the same time. It's paradoxical, but yet it works. How can something be a wave and a particle at the exact same time? And what's even crazier is that when you observe it, it completely changes its nature. Now bear with me here as I explain the experiment which started all of quantum mechanics. Picture this, a big wall of cardboard in front of me, with two vertical slits cut into it, and a screen behind it to detect electrons. Something remarkable happens when I start shooting electrons through these slits. An interference pattern appears with alternating bands of dark and light. This means that the electrons showcase a wave nature. But what's eerie about this experiment is that as soon as I place a detector on each of these slits, the wave pattern completely disappears. The electrons behave as if they were particles. No one knows why this happens. This is known as the wave function collapse, or simply the observer effect. It's as if the universe itself does not want us mere mortals to discover its secrets. Physics is a subject which transcends all barriers of language. If we are ever to find other intelligent life in the universe, they are sure to follow the exact same laws that we do. They'll know about the universal law of gravitation, perhaps through their very own version of Sir Isaac Newton. They'll know about the laws of conservation of energy and momentum. They may even have their own version of the periodic table, perhaps following the same method of arrangement as our own. This can be showcased on a much, much smaller scale on our very own blue planet. The ancient Greek mathematician Archimedes is credited with formulating the law of buoyancy, famously known as Archimedes' principle. What it basically states is that the upward force you experience in a body of fluid is equal to the weight of the fluid you displace. Pretty simple stuff. But long before Archimedes formally articulated this, it was being used by countless different civilizations intuitively in their boat-building processes. This means one thing. Boats, ships, and watercraft were not universally developed, but individually discovered. The very same thing could happen at an astronomically larger scale in our own universe. Now, as I move towards the end of my talk, I would like to showcase the collaborative spirit of physics by showing all of you this picture. This picture was taken at the Solvay conference in 1927, where scientists of the 20th century got together to discuss electrons and photons. You see great minds here like Albert Einstein, Marie Curie, Niels Bohr, and Erwin Schrödinger. What's interesting about this picture is not just the sheer intelligence which radiates from it, but the shared universal language that brought all these people from different cultures, different walks of life, all together, focused on one singular goal: to propel humanity forward into the future and to make it develop faster than it ever has. I hope that I've been able to ignite a newfound love for physics in all of your hearts. Thank you.